correctly that in looking at the breakdown on the grid box between Houston, Mexico City, and Portland, when you look at the 300 and the 100 laptop, they use a keyword where it says connecting to both. I took that to mean, I hopefully not incorrectly, that I would have to double that 100 to 200, which gave me a minimum of 550 for Houston. In terms of the connections I would have to
total,
account
yes,
for.
right.
Okay.
But we're
Okay.
splitting it off between wired and wireless, so you're only
Okay.
going to have 400 wired and 150
Gotcha.
wireless. But
Okay.
you're absolutely correct. In total, 550. So anyways, so I think we decided we were going to do 172.16.20.0/23. You guys remember what the /23 meant? Or why we decided to do /23 instead of /24?
CIDR notification that allows more subnets.
Correct. So we're taking one of the bits in the previous octet and using that for more computers rather than more networks. So so in decimal, that would be a 255.254.0 subnet mask that you would put into, really you'd program it into DHCP most times, or you can hard code it. So your default gateway. So your default gateway is going to be the address of the router you're going to attach to. Because in order to get out to the internet, you're going to need a router. And every network that connects to that router, is going to have an address on that interface. So it could be a physical interface or a virtual interface. But the default gateway, you can literally put anything in this range as that default gateway address. You have to program it into the router with that address though. So for me, normally what I like to do is I like to do 172.16.0.1/23. Does that make sense? Oh, not 0, sorry, excuse me, 20.1/23.
So Peter, quick question.
Uh-huh.
Do you need a gateway for each wired wireless connection? Is that what I'm understanding?
Yes.
Okay.
If the wireless is on a different network than the wired, it's going to have its own default gateway. So yes, you're correct. And so for the wireless, we're going to use that same, actually we don't need to have the 23, so we can use a 24 with 150. So we can do the IPs of 172.16.53 at 0/24, and then I got gateway on the brain. It means subnet mask instead. That's what that is. So what's the subnet mask on this one? 255, 255.
255.
Correct. You guys are getting it. You're getting there. And this default gateway, you want to kind of, since you're starting, we want to go in a pattern. So again, you could use anything in this range as your default gateway address. But I would just use 172.16.53.1/24 as your default gateway address. You could use instead, say 254 instead, if you want to do the top of the range. Whatever way works for you. I like the one just because it's simpler. And if you're doing your IP addressing like in a list of all the different networks and computers you've got on the network, the 172.20.1, you know, it's going to be the first in the list. So that's the reason why I like using the default gateway. It's just easier to manage for me. So then our server IPs, those are over here. So they want us to use 172.16.19.0/24, but we're going to have to subnets to that some more because we got to divide it up between Houston, Mexico City, and Portland. So in order to do that, it doesn't really tell us how many servers we're going to need. Actually, probably doesn't even mention them in here. So we're not going to worry about it. It's extraneous information in the instruction sheet because I don't see it. Yep. So we've got that. Let's jump over to Mexico City. So the IP is going to be, what did we decide? We decided 30, I thought it was 30 range. 172.16.30.0/24, which would be subnet mask. .255.0. And what do you think we should put for the default gateway for this? Got to spell it right too. There we go. Obviously, it's going to be 172.16.30.
0.1/24.
There you go. And actually, these 24s, we don't really need to have. They don't get put into your default gateway. So if you look at your internet settings on your computer, you click status, it shows your IP address, the subnet mask, and the default gateway. But it doesn't have any slashes or numbers behind it or anything. So the /24 would just let us know that we're on the right network. And then wireless IPs, we'll do actually, we really didn't get into that much. What do you guys think? I'm thinking since we're going to need 60, up to 60 for Portland, and we're starting at 53 over here in Houston. So what do you think about 56? That sound like a good number for you guys? Does that make sense at all? So that way I've got some extra room here, as well as Portland. In fact, Portland, I might use 59.
Well, when I was filling out the lab one, I was thinking like since Houston and Portland are like slightly bigger locations compared to Mexico City, I figured, you know, maybe give those two a bit more
Okay,
and give Mexico City a bit less.
that's absolutely valid. Yep.
I was thinking
I
the
mean, that's
same.
just
So I did, when I was
personal
working on the
preference.
wireless, I did 3, 2, 3 for Houston, Mexico City, and Portland.
So 3, 2, and 3. Oh, I see what you're saying. Yeah. Okay. then finally Portland IP 39. Let's go 0. I'm gonna default. It would really help if I could type today, but you'd much rather have me type this instead of doing it on the screen like Mark does. No offense to you, Mark, but my handwriting is horrible. You don't want to see that, so I'm going to type it out.
No worries.
All right, so does that make sense to everybody? They're going to have that gateway. And then, oops, not 39. We're going to 52. We're going to do 40s, I thought. So, yeah, 40. It was over here that we were going to do. One less. 72, 16.
What's the difference between 0 through 24 and 1 through 24?
What's the difference between 0
/ 24 and 1
Oh,
/
I'm sorry. See, I've got this. It should just be the straight number. Shouldn't have to do the slash behind it. This is the only one you have to have the slash on. And all the slash means is that this is the subnet mask we're going to use. So really, the way we've got it written here, you wouldn't even need this because you've already got it here. Does that make sense?
I still don't really understand all of this, but yeah.
All right. So we got all these numbers filled out. Let's take a look at the questions here. So what is the simplest subnet class to use when planning an IP addressing scheme for each of the branch locations? So this is actually a question that, because it was drawn from a Microsoft questionnaire. And so they're wanting you to use 2 separate IP ranges over here for Houston because you've got more than 256 computers. So they want you to use 172.16.20.0/24 and 172.16.21/.0/24 because that would be easier because it's got or easier quote unquote because it's got the subnet mask delineations in line with the octets. But there is no reason why you can't just use 23. To me, this is simpler than having 2 separate ranges for your desktop and laptop computers. Does that make sense? So the official answer for this would be to separate them out into 2 separate subnets. So the subnet class would be a /24.
Okay, I just fell off my horse here. Semantically, the question reads, what is the simplest subnet class to use?
Yeah.
And so I zoomed in on the letter classification, but you're suggesting that the question is really about establishing what we were intending is, do you need a single net, a double subnet, and what would that, how would you number that? I did not actually get that from the question semantics. So
if it's a class, so if you're going to do something class full, that would be a /24 then, a class C, in other words.
Right, which is what, that's what I wrote. But you're right. I didn't know whether that would be the only answer that satisfied it or whether like in the case you just put up. We might want to show an example, so.
Yep.
Yeah,
That's exactly it.
I also said C as well. I didn't really elaborate. I mean, I didn't really understand the question, but
Yeah,
that's what I said.
they really worded it strangely, so it's kind of
Yeah.
a trick question. It's one of the reasons why we're going through this, so we can have kind of a discussion on it, because in networking, they let you get away with a lot. And in fact, they let you, in my opinion, they let you get away with too much, because you can really screw up your network if you don't know what you're doing. So yeah, it's why training is a thing. Anyway, so number 4, in the Houston office, what is the number of potential wired and wireless clients? So I think we already covered that. So we're going to have the total is going to be 400 for wired and 150 for wireless. That's the potential that they could connect to at any one time. Now, obviously, they're not going to use that many.
What was the answer for number 3 again?
The class to use would be a class C or a /24 subnet. So in the Houston office, how many subnets are required for wired connections? So again, this goes back into that same question we had up here in 3. So they want you to separate it out into simplest classes. So you would use 2 subnets for the wired connections. In reality, you'd only use 1, or at least that's what I would do. Just use 1. And then how many are required for wireless? Then only 1. And what is the subnet mask for these subnets? So they're talking about doing a /24. Whoa. Bring me back to the questions. Doing a /24. But in reality, I would do a /23 and then also a /24. So /23 for the wired and a /24 for the wireless. In the Mexico City office, what is the number of potential wired and wireless clients? All right, so I gave you the answer for the Houston. What's the potential number of wired and wireless clients in Mexico City? Somebody want to let us know?
It's simply basically the wired ones also count, like basically you would count them twice in a sense.
Right, because the laptops will have both adapters available, and so technically you could use both at the same time, although the laptop would actually not do that. It would only use one of them. But they could connect, or they could with wire, or they could connect with wireless, and you just don't know. So you want to plan for the worst case. So what would that number be then? How many wired computers do we have to plan for? How many wireless do we need to plan for?
Well, I'm going to step off the dock into the water and say 70 of the wireless and 150 of the wired, because we're counting both one way and then the other.
Absolutely. You're 100% right. All right, and then how many subnets are required for wired connections and how many for wireless? I think we already covered that a little bit. Looks like only 1 subnet, even if you're doing the Microsoft subnetting style of doing classful subnetting. So 1 subnet per is all you need. And then in the Portland office, how many potential wired and wireless clients are we going to have?
Had 175 for wired and 225 for wireless.
There you go. And then how many subnets? Again, I think we already kind of covered that a little bit. We're going to have one subnet for the wired and one subnet for the wireless. All right, so given the assigned IP range of this range for wired clients, which subnet will you use for the Houston, Mexico, and City and Portland offices? Okay, so we already kind of discussed this on Tuesday and a little bit today about how we would use the 20s for the Houston. We use the 30s for Mexico City, and we use 40s for Portland. And then the 50s, they're just there for growth in case we even have even more growth than that. Does that make sense? And then given the assigned IP ranges for the wireless, which subnets would you use for Houston, Mexico City, and Portland, and then why? Okay, so I just kind of went by just kind of dividing them up almost equally. Sounds like some of you wanted to do something a little more because they have more computers, to give them a little more room because they might have even more computers in the future. And that's perfectly fine. That's perfectly valid. Good reasoning. Makes sense to me. So here I've given this one 512 addresses and I've only got 175 computers. So yeah.
I want to point out a stumbling block that I made in scribbling notes, late last night, is that obviously you're given the subnet requirements for wireless versus wired. So when you go to each branch, you've got to make sure and remember that whatever your numeric range is, that you separate that between the wired and the wireless. Because I think inadvertently I scribbled a succession like in the 20s when I should have dropped into, like what we did with in the example you did with the 50s, for the wireless. And I've corrected it, but that was a stumbling block. I wasn't paying attention.
Well, when I said the 50s, I mean like 51 and 52. So
right, and that sequence was given in that case. So you sort of says to desktop, but in the assignments for the wireless, you correctly, like in your examples for Portland, if you look versus the wireless on the other ones, you correctly associated like 56, 59 for wireless. And of course, if I wasn't careful, I was associating the city, for the range, and that was incorrect.
Right. Yep. Yeah. Well, I mean, you can do the city thing with the wired, but they don't give you enough addresses to do that with the wireless there. So you kind of have to just finagle it as best you possibly can to squeeze in the numbers to make it work. So.
And you've got two Class C's there for Portland, right? You've got the 40 net for wired, and you got the 59 net,
right,
for wireless.
Yeah.
So 254 usable addresses, right? So which covers those. Your 225 laptop and tablets. So you are getting close to that upper bound with the wireless, looks like.
Yeah, a little bit. It's getting close. Yeah, so I could make this a either two separate addresses and use 172.16.59 or 58.0/24 as well for the and give them additional. Or I want to say I'd have to put in the subnet calculator to figure out what the actual subnetting part of that would be.
Yeah. Yeah. Where does it break up?
/23.
Yeah. So those two together would be 512. You have two separate Class C's that you could put on the router. There'd be this primary and a secondary. But like you say, with a /23, if that's 58 and 59 or whatever, you could do that as well. Those two would be combined then, as seen as one subnet. Yeah. And of course, your mask then would be changed. Each of these independently would have a 255.0 mask there, but But combined, you'd have to make that, if you did a /23 for both of those together, your mask becomes 254.0.
Well, what you'd also have is you'd have well, yeah, you could either do a 254 or you could do two separate default gateways.
Yeah, that's right. You would have two separate networks, and it's one of those things where it's a weird deal, but you can actually have a primary or secondary subnet on the same interface with a router, and so effectively it's like you're divided in half on that in that sales office or whatever.
Right.
But they talk to each other through the router if you're on 58 versus 59, whereas if there's just one, like a 58.1 is your gateway and you have a /23, then they're all seen together as the 58 and 59 then join together to be one bigger subnet.
Yeah. And then also with wireless, you could make two separate SSIDs and then associate one of the SSIDs with this range and then associate with the other SSID with this range. There's a wide variety of the different things you could do just for management purposes. You have a sales wireless SSID and a marketing wireless SSID or whatever, a training SSID, whatever. So yeah, I mean, there's a wide variety of things we can do that would work and also fulfill the requirements of the scenario here. So number 12. So how many default gateways we're going to need?
One gateway for each subnet.
Correct. And how many is that going to be?
It'd have to be 6 then.
It's either 6 or 7 if you.
Yeah, depends
go.
on how you've got it set up. But yeah, 6, possibly 7, possibly 8. Because technically they wanted us to split this into two separate subnets. And so you'd have a default gateway for each of those. And then if we did two separate subnets over here, that'd be a default gateway for each of those. So that'd be a total of 8. So, but minimum 6. Does that make sense? Y'all are following today?
So if you did like a 3-2-3, you would need 8 then, right? 8 defaults.
If you're going to do 3 for wired IPs,
I think so, right?
Okay. So if you're going to use 3/24s.
Oh yeah, make the slash. Yeah, say the /23. Then we know that's what you mean. Yeah, they're cider. So 3/23 subnets for Houston, Portland, and Mexico City, right? So you've got 512 addresses per. Yeah, that covers you for wired, but again, they wanted to split up wired and wireless. So when you look at the wireless, you're like, okay, well, what subnets do we want there? Because they, for whatever reason, I think this was just this academic, exercise of divvying this up. You've got, technically, you could do a /23 and put the wired and wireless together if you wanted, right? But maybe for management or whatever other purposes, you're setting them up separate. So yeah, that covers your 3 wired, but then you still got 3 wireless to go as well. So
I think this is what he was trying to say he wanted to do, 3 separate subnets rather than trying to combine them all. And if I was going to do it, I would do, instead of a 23, I'd do a 22 then and give 1,000 addresses rather than assigning separate. That's what I would do at least.
Because then what you've got is effectively, you just have one subnet that covers 4 class Cs. It just combines 16, 17, 18, and 19 together. Sorry, 20, 21, 22, and 23 together. Yeah, sorry. Yep. I was looking at the second octet. Yeah.
Yeah.
21, 22, and 23. That's what it would combine together. Give yourself 1,024. And your mask would be 252.0 at the end, you know, those last
Yep.
two alphabets.
Yep.
And you'd have 1024, and you just have used a group of 4 combined
And you
together.
wouldn't have to change your default gateway.
Yeah. Yeah, you wouldn't have to change it because you know you already had 20 to begin with. And 20.1 still works for the gateway. That's the IP address of the router. Yeah.
Can I ask you a generalized question, Peter?
Sure.
This notwithstanding on this worksheet test, there is such a thing just talking about best practices. And I know that you guys in this have pointed out that you're specifically mentioning the wired and wireless. So in my mind, you're suggesting maybe in best practice, you should always, if you can, separate those two. But maybe in a case of a very small company, it would be ridiculous to do that. But in most cases, in what you've done with these examples, it would be best practice. Also, too, it wasn't mentioned, but sometimes geographics plays into it. Is that also best practice? Like in the case of Mexico City, if we have like an office, you know, on one side of the city and an office on the other side, that you use geographics as a kind of thing. We haven't talked about it, but there's other things that go into whether or not you want to regionally use those numbers.
Okay, so it depends on how you want to manage things. It depends on also how centralized you are. If you've got one central office and pretty much everybody's a thin client on the other side, it doesn't really matter where they're at. So like, for example, like a situation where you've got a whole bunch of people that are VPNing into your office. So they might be on the other side of the world. You're only going to hand out a certain range, one range to these people to connect to you with. So in that case, yeah, geographics wouldn't make any difference. But if you've got a bunch of locations that have their own servers, their own data centers in them, that would handle their own, I guess, redundant systems on, say, different parts of the country or different parts of your county or state, different locations, and just for management purposes, then yeah, you could assign an IP address with a location number. Kind of like what I had mentioned where my last job I was at. We had 72 locations and each one had a separate IP range. And it's just the way they decided to implement their network.
That also then suggests to me an additional question about in a case where you have like an upper echelon, for example, SMU staff and faculty, or an organization like in police jargon, you'd have different TAC frequencies, so to speak, where maybe you want to assign a tier to a specific type of admin. Because I know that in just general practice, you could group everybody to where you can't see this person or you can't involve yourself in that department because you can group policy that. But would there be any credence to you using methodology in designing a network to give your admin a separate IP section?
Right. So the answer is yes, there is a definite reason for that. So we haven't really touched on the security aspect of doing different IP addresses and networks and all this type of thing. The reason why you'd want to subnet into a different departments, that type of thing. Your router has the ability to do what's called an ACL, access control list, and it's done on the layer 3 and layer 4 type implementations. So you can basically say these IP addresses can talk to this IP address, but not this IP address. So basically you can then say, yes, we have an admin set up and nobody can talk to them except for the admins, and they can talk to certain servers and the internet. And you can set it up that way. And it's very, very secure then to do that. So yes, absolutely. The different departments tend to get different IP address ranges just for that purpose.
Thank you.
All right, so that's kind of the end of that thing. What other factors? We're kind of touching on that right now with security factors. Any other observations you guys would have or questions you would have about our Houston and Mexico City and Portland networks?
I was going to also ask about redundancy. Sometimes your network in a growing company, you try to keep it within minimum, save money, but there's such a thing as redundancy, like when talking about server farms and how they do backups, or how your company may need to have a records depository, or a company, I should say. So there's a consideration that you're going to need IPs maybe for additional services that are beyond just the scope of the productivity terminal, so to speak. So I don't know.
No, you're absolutely right. In fact, most servers have more than one network adapter on them. And a lot of times you can combine them into one. It's called NIC teaming. But you could also separate them out into 4 separate networks if you like. You can actually turn your server into a router, although I don't really recommend that, because usually you'd want a dedicated device for your routing, and then your servers would do the serving. But you can do it the other way and turn your server into a router. It's absolutely something you can do. On the other hand, also some situations in a data center, like where you have what's called a SAN, where it's a data storage. A lot of times their recommendations and best practices, they're going to be on their own separate network. And so what you want to do is you want to put your server, one of your legs to be on the normal network and one of the legs to be on the storage network, so that it has a dedicated line to your storage SAN. So it's faster and more reliable. And then yes, absolutely, there's all the reliability issues as well. I don't know if you've looked up any of the network diagrams for data centers, but they're very complex. They've got it's kind of a mesh network. I don't know if you've ever seen a example. Let me get onto a new tab here.
Yeah, while Peter's looking that up, you can push when you have lots of very high-end networks. You're going to push different traffic over different networks. So backups over one network. You're going to push management traffic over another network. You're going to push production traffic for these clients over another. That way, it's more secure. It isolates it. It limits the broadcasts and the traffic, so you don't get congested with backups or administrative traffic. Those are on separate networks, and those can be then pushed out and isolated, and gives you more security that way.
Mark, I'd like to ask you a question, regarding that. I don't want to get outside the scope of the CSC 345, but things like load balancing, where you just mentioned we're pushing different levels of traffic. In cases where you're noticing that you are experiencing exceptionally high traffic volume, there is also, I suppose, methods that can be applied to help equalize that. Could you address that in some small way?
Yeah, traffic shaping can be done, where you can say, hey, what's our highest priority traffic? And then you can actually carve out specific bandwidth on that subnet to provide, so you never run out of bandwidth. If you've got, say, a video conference room that's on that floor and that's your subnet, you want to make sure you have enough bandwidth that you never, somebody's in a video conference and then somebody does some big query or some download of some file or something, or pushes a lot of management traffic on the wire, and then all of a sudden you don't have enough bandwidth left to run your video conference, and so it starts to drop, a connection starts to fail, people's voices or video starts to pause or drop. So what you do is you do traffic shaping, and then you have appliances, they can be virtual or physical, that you will actually shape that and carve out that bandwidth. And then, yeah, people, when they're trying to send a file or copy a file, maybe it takes a little bit longer, but what you're doing is you're limiting them, you're rate limiting them, so that they don't dig into that bandwidth that's needed for like a video conference room or something, like a dedicated video conference room. Yeah, something like that. Peter, you want to add to that?
Sure. Well, I pulled up the previous question he had about redundancy. You've got this is an illustration of what a data center network would look like. So you have a core set of routers at layer 3, and they talk to other routers. They'd be possibly an individual or a group of server stacks at each of these routers. And each of these routers has one leg going to each of the core routers, so they're redundant. So if one of these core routers drops out, you're still able to talk because you're able to go out to the other core router. Or if one of your interfaces goes out, you're still able to talk on the other interface. So yes, it's, and every link talks to each other, so it's kind of a mesh type network. And then you have a layer 2 set of switches that are on each cabinet for the servers, which then connect all the servers together. And those are also redundant. And then those connect to the layer 3 switches in a redundant manner as well. And that's what they're illustrating here.
Yeah, I want to add on the load balancer. I just want to say that there is a strategy that, like multiple strategy that you can just, such as like round robin is one of the most famous one. And also there is a hot model, the one that going to the hot, keep pushing it and separate from the cold one, or there is a less work, or there are multiple different options aspect for the load balancer or for the data distribution and redundancy. It's matter of what's pros and cons and how you can choose for what budget or whatnot.
Question that we had earlier before you got on, Mark, was when are we planning on having our quiz? I was thinking Tuesday. Is that right?
Yeah, Tuesday.
Okay. All right. So, and then when would it be due? I was thinking by next class period, Thursday.
Yeah.
Okay. All right. Just making sure I'm on the same page as you. So, let's see here. I guess, do we want to quickly review? We don't really have a lot of time. We got like 3 minutes. I would say remember this setup here where you have hot and cold aisles, and the hot air goes up into a plenum. You have the crack unit that will cool the air and push it up under the floor. And then I would also remember the RJ45 connectors and your cabling colors, especially the B spec. That's what everybody uses, is the Bs. You could use A if you like, but everybody like standardized uses B. Let's see here. It's hard for me to grab a hold. There we go. Then also remember our chicken coop data center. Remember that, what that was for? Why they designed it that way?
For the air circulation.
Right, because it doesn't have active cooling, it uses outside air for cooling. So I guess it would be active in the fact that it's got fans that blow it in, but it's not like chilled. So, and then remember we had the Microsoft data center underwater. Thought that was pretty cool. And then remember our cabling with fiber optics. You know, we had the wire, the copper, the RJ45 and the different colors. But then fiber optics, they've got either single mode or multi-modes available. And usually that's yellow and orange, although that's not really standard. The new ones are teal in color, the multi-modes are. So the orange ones are actually kind of an older standard. And that's pretty much what I was going to review, actually. So I did that quick. And then of course subnetting, that's going to be on our quiz. So,
If we add one more thing to right here, this link aggregation, if you expand that a little bit with, you've got the redundant links. Remember that everything, when you start doing redundant, you double your costs, right? Because you have to have double switches, and ultimately you have to have redundancy in everything. Because if you did all this redundancy and then you just had one port that went to your server to one NIC, and the cable, there's a problem with the cable, or the port failed on the switch, or the port failed on your NIC, or something like that, you're still down, right? With all this added infrastructure cost to make this all redundant, if you have one single point of failure anywhere along this route, and that fails, well, then you're down, even though you had all this other stuff redundant. So when you do that, when you get to some edge, or the core goes to some internet router or something, then you're like, okay, well, I need to have 2 feeds to the internet then, right? Otherwise, if I just have a 1 feed and that feed goes down, well, then I'm down. So that's why you have to have redundant servers in those redundant NICs. Those NICs use what's also link aggregation, which is you can have 2 links into a switch, but it's called NIC teaming. That's what Microsoft uses for Windows. And you say, okay, join these 2 NICs together, and they're seen as one big NIC virtually, even though you got 2 physical NICs and 2 physical cables that plug into the switch. And with link aggregation on the switch and this NIC teaming on the server, then if one of your servers fails, you got the other, or if one of the NICs fails, you still got the other, although half the bandwidth before. And so yeah, it's an expensive proposition, but how do you get to a point where people do not see downtime because stuff fails? Hardware fails, software fails. You have to build in redundancy at every level. And so that's, and if you did all this redundancy and you had one single cooling system and the cooling system failed, right? So you have redundant cooling systems. So you have redundant backup generators. You have redundant data centers. What if there's a catastrophic failure? You got a backup data center. So it just, there's a lot to go into it. There's a lot of expense for us nowadays. We take it for granted. We go to the internet and stuff is always running. Rarely do we hear about an outage. Like all of a sudden some big company had some outage. And just, want to remind you that every element has to be redundant then to get very high availability rates.
Yep, and just a quick story about here on campus. We try to do this as much as we can, to have the redundancy and availability on it, things. Sometimes the expense just gets to be too much. Like we can't do 2 separate service providers for internet. That would be cost prohibitive. So we only have one of those. And then also we got bit by a couple months back is a power outage took down a whole bunch of servers on campus because the one generator went out. So we didn't have a backup generator to power everything on. So yeah, if you're actually running a real data center and not on a school campus, then yeah, you're going to have backup generators, you're going to have battery backups, you're going to have redundant service providers for internet, and ideally you want one to go east and one to go west, or one to go north and one to go south on the cabling, so that if some Yahoo out there decides to take a backhoe and dig up your fiber, then you won't get your entire data center cut off. It'll be only half of it cut off. Does that make sense?
And sometimes that's just not realistic. Sometimes you just can't do it.
Yeah,
Financially,
sometimes.
costs are, so you have, you think, well, why wouldn't everyone do this? Well, it can be cost prohibitive, and you have to make a decision. Okay, how much? There's a cost benefit return here, and if the mail goes down or the email goes down, our mail server, okay, for a couple hours, are we still okay? And you have to evaluate that as an IT department. Is it important for us to make this so that it never goes down? And so you can build in and you can add that expense, and that's why some people are like, well, why would people put always the top level security into a website or whatever? It's like, well, all I've got is just my, a simple website for my company. I'm a plumbing, company, and I don't want to spend a lot on this. I just want people to get my phone number and my address to find my plumbing store. So if they get hacked because they're using an older version of JavaScript or whatever, you know what I mean? There's nothing on there. But if you are Target and you have a Target credit card and you have PCI DSS standards for payment card industry, digital security standards, and you get hacked, you can be fined. Not only that, you can lose credibility for Target customers. I'm just saying this because Target got hacked and millions of customer personally identifiable information and credit card numbers were exposed. And that's a black eye. So it's worth Target's efforts to add the highest levels of security and to have people constantly checking and monitoring and validating and making sure everything is to the latest standards and availability. That stuff doesn't go down. You can't go to target.com and then all of a sudden it's not there. Or Amazon. If you couldn't get to Amazon and you wanted to buy something, that's not good, right? So.
Yeah.
All right, any questions?
I do have a short one, and I'm sure that probably won't be able to cover it today. We kind of covered the idea of setting up network planning in its basic form and learning these subnetting. But you touched on something about resource allocation and considering load balancing and things. And one of the examples that came to mind was where, let's say, some scientist is running an experiment on his computer that somehow or another keeps the main server occupied, and it starts to, through its distributed policy, using up resources, across the net. Are we at some point in this class, or should we just, I'm looking in my mind, will we see how to configure a router or configure certain ranges of features that will not allow an individual user, so to speak, to interfere with network operations?
I'm not sure.
It's tough. I may need to go get the specifics. I heard of an example, and you guys may know him. Greg Larson, coming from the state, talked about a bunch of examples to where they had people who sometimes ran their systems 24/7 to do certain things. And when everybody logged off out of their departments, then the computers would then allow more resources. And imagine that whatever experiment or whatever this person was doing in record checking or coming up with the statistical analysis, it ended up hogging so much memory that it bled over on its core servers, and it began knocking out access. So the other people were losing services because this particular connection that was running a multiple level of memory use and resources that otherwise, and I don't know how you do that as a network planner, network engineer. I'm guessing now that you simply just limit this guy to, a couple of channels and so much memory use, but at the time it shut down the network. I don't know if this class is going to get near that, but to me it struck me as a network issue.
So what your example is talking about is where you had one massive server and you had multiple programs running on it at the same time. Nowadays, what you'll have is a group of servers that are massive, and they'll have VMs running on them. So it'd be a virtual machine. So everybody that would have their own program would have their own virtual machine, and then of course you're limited on how much memory and processor you can use at that point. So it's a lot easier to manage nowadays. But yeah, back in the day, yeah, it was difficult, and there you had a lot of different outages, and It's actually one of the reasons why they came out with virtual machines, just because of that type of problem where you'd have a problem with a server and it would knock out a whole bunch of different services all at once.
Yeah, so there can be a huge query, and let's say you had a database of millions of records, like the state, and then you're running through millions of records in a query, and you are utilizing a server to its maximum extent, running this massive query to generate this report or something. And so that's an individual issue where the server can become unavailable because all of the resources are being utilized on this query. So other people trying to access or add data into the database are being dropped because you don't have access. Now, you can get dropped on the network simply because your resource at the end of the network is 100% utilized and it can't do anything else but run this query. So that may not be a network bandwidth, but be a utilization of the actual server. Then there's other times where thousands of people are using one database, and so they're all trying to access it, and the bandwidth of transmitting all that data to all of these different users on the same subnet can overwhelm the pipe or the link between switches and that server and the other client. So bandwidth can be an issue, or delay in response, latency, okay, based on the utilization of that server. So it can be a utilization of the server. It can be a bandwidth issue. It can be just the amount of connections that server can support. If it can support, 1,500 connections, every second, but you're running it, 2,000 people are trying to get on that thing and do stuff, something like that, so there's intermittent connectivity, people are getting dropped, so slowness. So that's where troubleshooting comes in. Okay, what is the root problem here? Is it the network? Is it the server? Is it something else? Is it security? Is it, is it a back-end storage issue? So so a lot of things can come into play when you're dealing with slowness or loss of connectivity.
All right, so we're pretty well done for the day. If you got any other questions, let us know. But that's it for the class today.
Well, I obviously missed my drop in the box on the homework, so I'll try to tidy that up and go find the right drop link for that. So I'll put that in as quickly as possible.